Hi again, everyone. I'd like to welcome you back to my YouTube channel. If you are new, subscribe. I'm Andrew Commander and I do educational videos on the CAPS curriculum. So in the previous video, we were looking at, of course, discussing mid-latitude cyclones. The previous videos will tell you or indicate to you that we were breaking down the general characteristics. We went through and discussed the areas where mid-latitude cyclones form. We also looked at the conditions that are necessary for their formation, and of course the stages of development, okay, and the related weather conditions. Okay, now if you tuned into that video, you should remember that we said that in the next video we will be going through the weather patterns associated with occluded fronts, and also discussing how you interpret or how you identify these mid-latitude cyclones in satellite images and synoptic weather maps. Okay, so if you haven't tuned to that video, I will leave a link in the description box, and it should appear on the top hand right of this video. Right. So without any waste of time, guys, let's just get into it. Right. So before I get into the gist of this, I just want to discuss something really quick. Now, in the past videos, we said that whenever you have an instance where a cold MS is converging or meeting up with a warm MS, we said that what happens is that the cold MS tends to wedge underneath, okay, and the warm MS tends to rise up. Okay, so it will rise up, cool down, condense, forms clouds, and it will result in rainfall. Okay, so that's what we said happened, but we did not really discuss this into depth or into detail. So let's really look at this again. So let's say you have, say these two MSs, you have cold, this is a cold MS. So by cold, what do we really mean, guys? What does cold entail? What does it really mean in terms of the value, okay, in terms of the temperature? Okay, because you can have a cold, okay, let's say a cold MS and a cool MS. Okay, so now what happens? So you have a cold MS and a cool MS. Okay, or what happens if you actually have or end up having an interaction between a very cold MS, okay, and a cold MS. Okay, so we need to look at these, guys, because there are interactions between these as well, right? So now the important part in this, or the important condition, it comes to the temperature, right? So temperature in this case, so between cold and cool, cold could be, let's say cold could be -7 degrees Celsius. Okay, maybe not -7, let's say -3, right, degrees Celsius. And cool could be maybe 2 or 8. Okay, so but relative, it's a relative term really. So cool is slightly warmer than cold, okay, and then very cold could be maybe -10 degrees Celsius, and cold could be exactly -3 degrees Celsius. Okay, so which one is relatively warmer than the other? This one is, right? So what happens then when you have these two MSs interacting with each other, moving towards each other? Okay, so converging, right? So the same concept, guys, we apply the same concept. So let's take this instance for an example. So you have a cold MS, right? So which is so cold in this case, that's -3 degrees Celsius, and it's converging or meeting up. Sorry about that. It's meeting up with a slightly warmer, but rather we use the word cool. Okay, so it's cool. So it's as I said, 2 degrees Celsius. So it's a relative term, really. And so as you can see that the cool MS is slightly warmer than the cold MS. And so what happened? Which one is denser? First of all, you definitely know that the cold MS is denser than the cool MS. Okay, excuse me. And so what will happen then? So the cold MS will move underneath the cool MS, and the cool MS will rise up, right? So the cool MS, or you can say that the cold MS actually pushes the cool MS up. Okay, as what happens, this is exactly as what happens when you have a cold MS and a warm MS. The cold MS, we say that it pushes up the warm MS, right? Or we say that the warm MS actually rises above the cold MS. So that's really what happens. So the warmer MS in any situation or scenario, the warmer MS will be pushed upwards. Okay, so this also applies in this instance as well. Okay, where you have a very cold MS and a cold MS. So what does that mean? The very cold MS will wedge underneath, and the cold MS will be forced to rise like that. Okay, so that's what it comes to density, guys. It comes to the temperature. The coldest MS will wedge underneath, and the relatively warmer MS will be pushed upwards. Okay, so I need us to hold on to this because it's very important when you are discussing occluded fronts. Okay, and in order to understand the difference between warm front occlusion and cold front occlusion and warm front occlusion, you should be able to understand this first. Okay, so this is the foundation, right? So that means that if I actually have a cold MS, which is -3 degrees Celsius, a cool MS, and a warm MS. Okay, so let's say a warm MS also moves towards this. So we have two MSs of different densities moving towards cold MS. So a warm MS would be, say, 20 degrees Celsius, right? So cold MS will lift both of these up, okay, because it is just a denser air mass, right? So it will be able to lift or push these two up, okay? And so of course these will get colder and colder, and this will therefore result in cloud formation, okay, and therefore result in rain. Okay, so that's how it goes, guys. Okay, the coldest MS or the densest MS will push the less denser MSs up, and this will condense, and this will result in rainfall. Okay, especially if the air inside of these is moist. Okay, should be warm and moist, right? By moist, again, guys, we basically mean that it has high um, water vapor content. Okay, so this allows it to condense, form clouds. Remember, clouds are made up of water particles, and so that's the most important. That's one of the. I mean, that's one of the important prerequisites or conditions. Okay, in order to form clouds and rainfall. Right. So let's look at these. Let's look at the difference in these. Okay, we already studied mid-latitude cyclones. We said that they are made up of course, cold front and warm front, and we said behind the cold front there should be cold air, behind a warm front there should be warm air. Okay, so applies as well. But now I need you to really look at this. So a cold front occlusion. Okay, so when we're saying cold front occlusion, what you should really think of is that the cold front, okay, or the air behind the cold front will lift both the air, will lift both the MSs that are in front of the cold front. Okay, so this air right here, so this MS, right here, all of these MS will lift both of these warm MS and also the cool MS, right? Okay, and when it comes to the warm front occlusion, this warm front, okay, so the air that is actually ahead of this, remember we said that this is the front part, okay, of the warm front. Now if you haven't checked the video, again guys, you should I would advise you to look, tune into the video, the previous video that we made, which was of course looking at mid-latitude cyclones. Okay, all the dynamics, everything that you need to know, okay, is there, right? So we're saying that this is the front part of the warm front, okay, the semicircles. So that means that the air, so with warm front occlusion, we're actually saying that the air in front of the warm front actually lifts up both the air that is behind the warm front. So that's what is actually happening, but you might not get it right now. So let's just basically get into it then. Okay, now first of all, we know that this whole region over here, that is what we call the cold sector, right? So this will have relatively colder air than the air that you will find between these two, okay, or the air that you'll find ahead of the cold front or behind the warm front. So this region right here is filled with warm air, and we call that region the the warm sector. Sorry about that, the warm sector, right? So that's always going to be true. So the warm sector will have relatively warmer air than the cold sector, always, right? Right. So let's get into it then. So a cold front occlusion, this is how you explain it. So we see that the air ahead of the cold front is slightly warmer than the air behind the cold front. What MS are we talking about? Air that is ahead of the cold front, which MS are we talking about? We're actually referring to this MS. Sorry about this MS and this MS. Remember, all of this is ahead. This is in front. This is the cold front, right? So this is all ahead of the cold front. So we're actually referring to both of these MSEs. So we're saying that the air ahead of the cold front is slightly warmer than the air behind it. Remember, this is warm air. This is your cool air. Okay, so this is your -3 degrees Celsius, right? And this is your 2 degrees Celsius. This is your 20 degrees Celsius. Okay, I'm just making an example here, right? So remember, we said that if you have a cold MS, okay, a relatively denser MS, that if your MS is relatively denser than the other, then the MS that is denser will be able to lift up any other MS that is less dense. So in this case, we'll be able to lift up both the warm MS in the warm sector and the cool MS in the cold sector, right? So all of this cold air right here will be able to lift both of these up. Okay, so from a side viewpoint, so we're having a cold. This is your cold air, and you have the warm air, right? And also the cool air, right? So this is your warm air, and this is your cool air. Both of these, I'm saying, they are going to be lifted up or pushed upwards by this cold MS, right? So they are both going to be lifted upwards like that. That's what we're saying. Okay, so that's what we mean. So you have to really know the words, the correct words. So the air ahead of the cold front is slightly warmer than the air behind it. So what happens now? This causes this warm and cool air to be lifted along the cold front. That's exactly what I'm saying. So this causes this warm air right here and this cool air to be lifted above or along this cold front over there. Okay, and then the rising air does what? It cools. What next? It condenses and forms these specific type of clouds, the nimbostratus clouds, and this results in rainfall. Okay, and that's it, guys. That's how you explain the cold front occlusion. Okay, so how do you identify? We'll look at the difference after I've explained the warm front occlusion. Okay, so the most important part comes to these temperature differences here. You have to look at these MSs, okay, because they change when it comes to warm front occlusion. They switch up, okay. But of course, the warm air will always be in the room sector, right? But these two switch up. So that's what we're saying, guys. Saying that cold front occlusion, warm air that is in the warm sector and the cool air that is in the cold sector gets lifted along the cold front, okay, or above, or is pushed up by the cold air behind the cold front, right? I just hope that doesn't. I hope you get it, guys. I just hope you don't get confused by, of course, the words and stuff. So that's the cold front occlusion. Okay, this is the end. This is when, of course, the end is occurring. So the end of the cold front, right? Or the mid-latitude cyclone. I mean, the occluded stage. Okay, this is the dissipating stage. So a cold front. Another thing, an occluded front is how you identify it. Okay, here's how you identify it. It has those um, triangles and semicircles. Okay, on one end of the line. Okay, so as you can see like that. So you should be able to draw them, right? So that's how it looks like. Okay, so that's just um, extra information. Let's head on to the next type of occlusion, which is warm front occlusion. Okay, I know this can be confusing, guys. So the warm front occlusion now, what's the difference do you see now? What difference do you see? We definitely do see that, okay, behind the cold front, now there is cool air, okay, and ahead of the cold front, or ahead of this warm front, there's actually cold air. Okay, so as you can see, these two have switched up. Okay, that's how you identify. You have to look at these guys. They can just draw these to you, but they will never leave these, of course. They will never leave the temperatures of these. They can maybe use words, or they can use actual temperatures, okay, of the MSs in these different regions. So over here, you can definitely see that um, which you can definitely see that the cold air that is ahead of this warm front, okay, um, will actually lift up both. Okay, let me do this. It will actually lift up both the warm air and the cool air that is right in the warm sector, and of course behind the cold front like that. Okay, so let's see what's happening there. Okay, so the same concept, same principle applies. So saying that the air ahead the cold front is slightly cooler than the air behind it. Okay, so I think I must have made a mistake here somewhere here. So it should be the air behind the cold front um, is cooler than the air ahead of it, I think. Okay, right? Yeah, slightly warmer, slightly, or maybe it should be air. Yeah, I think this. Okay, so the air, excuse me for that. So the air behind, okay, let me reduce the volume there. So the air behind the cold front is slightly cooler than the air ahead of it. Okay, yeah. So by the air ahead of it, we're actually referring to the air that is in front of the warm front. Okay, yeah, it should be like that, right? So, and then what happens now? Now this results in the air behind the cold front and the warm air in the warm sector. Okay, this is the air message that we're referring to. The air behind the cold front, this is the cool air, and the warm air in the warm sector. Okay, to rise over the cold air ahead of the warm front. Guys, I know it can be confusing with the ahead, the behind there. Okay, but you just have to really get a hold of it. Know the front of which the front of which front, and of course the behind of which front. Okay, like that. So you should be able to describe it on your own using your own words. Okay, you don't have to copy this or anything. Right, so this results in the air behind the cold front and the warm air in the warm sector to rise over the cold air ahead of the warm front. Okay, so as you can see now, it's the warm front that actually, pushes these two along it or over it. Okay, in for the warm front occlusion, and then in the cold front occlusion, it's the cold front that actually pushes the air ahead of it, over it. Okay, so that's you can look at it that way. Okay, in order to differentiate between the two. Okay, it's very important that you know the differences between these two so that you can be able to identify them. Okay, in any scenario. Okay, so of course, this cool air behind the cold front and the warm air in the warm sector will rise up over this cold front ahead of the warm front. The rising air cools, it condenses and forms same clouds, nimbostratus clouds, okay, and therefore resulting in rainfall. That's how you write. That's how you describe how cold front occlusion occurs. That's how you describe how warm front occlusion occurs. Okay, there's nothing much, guys. Okay, that's it. This is it, right? Um, so that's how you identify the different the how that's how you describe and identify the different occlusions. Okay, let's look at since we were talking about mid-latitude cyclones. By the way, I got this from the Department of Basic Education. You can get this. This is a study guide. Helps you guys, right? It's a very very important resource. It's very helpful. Okay, trust me. Guys. You can find it at the Department of Basic Education website. You should get it there. This is a screenshot from that. So right over here, remember guys that you should be able to identify, interpret mid-latitude cyclones in satellite images. You should be able to identify them in synoptic weather maps. I'm not going to get deep into it, but I'm just going to tell you the important points, okay, to identify these. Right. So for some of you, you've already done mid-latitude cyclones and tropical cyclones. So for those of you who are writing, those of you who have been studying for themselves, so you must already know the difference between those two. So for the satellite image of a mid-latitude cyclone, it's a spiral, guys. So you should look at the spiral of clouds, okay? And the spiral really tells you a lot about the rotation of air, okay? So the air, of course, will follows the spiral, okay? So these clouds are influenced by the air rotation. So you can already see, guys, that this mid-latitude cyclone must or should be in the southern hemisphere because we see what? Clockwise rotation of air, okay? So these clouds imitate the the rotation of the air that is inside this mid-latitude cyclone. Okay, so that's the evidence that you use in order to identify weather, because that's what they like to ask. They would ask you that in which hemisphere is this mid-latitude cyclone occurring. Okay, so you look at the spiraling of clouds, because they can spiral like this. If they spiral the opposite way, so you can just draw. Okay, maybe just let's say just draw. Okay, try to draw um, arrows, okay, so that you can see the circulation that we are referring to. Okay, just follow this the spiraling of these clouds, and then you can tell the type of rotation, and therefore you can tell in which hemisphere do we find this particular mid-latitude cyclone. Okay, so that's how you identify mid-latitude cyclone. It's spiraling. It's not like your tropical cyclone. So a tropical cyclone will have a band of clouds like that, and it will look like a CD. I don't know if you guys do know what a CD. I'm sure you guys do know what a CD looks like. So it will like be very clouded around, and so it will not show any spiraling of some sort. So it will be like all clouds like that, and it will only have a hole in the middle like that. Okay, so that's how you then identify a tropical cyclone. Okay, so that's a tropical cyclone. Okay, so it has clouds in this case, um, that are like filling up the whole entire area surrounding this hole in the middle, which is the eye. Okay, and this is how your mid-latitude cyclones look like. They form the spiral, right? So that's how you identify them. Okay, and let's take a look at how would mid-latitude cyclones look like in the synoptic weather map. Okay, so of course, guys, synoptic weather map, we use lines, we use points, so on and so on, some vector data, and so you should expect, of course, the cold front symbol and the warm front symbol like that. So as you can see over here, that's how you identify a mid-latitude cyclone. Okay, so there should be a low pressure there, and L, as you can see, the letter L, and warm front and cold front. Okay, so that's indeed a mid-latitude cyclone. So it's pretty easy to identify it, right? And of course, we'll take a look at the tropical cyclone. And then this is the cross section that you should also be able to draw. Okay, it's very important that you are able to draw a cross section of a mid-latitude cyclone. Have your surface there. You have a direction of movement, okay, which is from west to east. Okay, direction of movement. You should write that down. You should have a cold front which should take that shape. Okay, should take this shape, guys, because this is indicative that a cold front is always associated with a steep pressure gradient. Okay, so a steep pressure gradient is simply indicates to us that there is high wind speeds along that front. Okay, and that air is actually rising up rapidly. Okay, this is very important, guys. Steep pressure gradient is very important. So the word steep, so this is indicative of the pressure gradient, that it is steep. So I'm saying that steep pressure gradient implies that you have a very high, relatively very high wind speed along this cold front. Okay, and also you have rapidly rising air. Okay, so the air that is going to rise up, okay, the warm air. Remember, this is your warm sector. This makes up your warm sector, right? So you have warm air here, and the warm air rises above or along the cold front, and it doesn't rise slowly. It rises very, very fast. Okay, very fast, very fast, and so that's why you are able to build these tall cumulonimbus clouds, because of the steep pressure gradient, rapidly rising air. Okay, these tall cumulonimbus clouds. Okay, so that's why they are associated with them. Okay, because of the steep pressure gradient. And that's how you should describe how cumulonimbus clouds actually occur. Okay, you should mention the steep pressure gradient, rapidly rising air. Okay, if air is rapidly rising, that means a lot of moist warm air is actually rising up, and hence it tends to build up these tall cumulonimbus clouds. Okay, and it's associated with heavy rainfall. So you should be able to annotate everything there. Okay, write heavy rainfall. Okay, write down. Um, okay, should write down. This is the cold front. Okay, write down. This is the cold air. Okay, in the cold sector. Okay, annotate everything. Okay, unless they tell you, you should maybe indicate some or some kind of details here. So in here you have warm air. Okay, and it's rising up, guys. Okay, warm air rising. Annotate. This is the warm sector. Okay, there we go. And you have this quite relatively gentle slope, which represents the warm front. Okay, so this is the warm front. Why is it gentle, guys? That's because the steep the pressure gradient, I mean, is gentle. Okay, so this is associated with a gentle pressure gradient. That means air along this is actually rising slowly. Okay, it's not rising as fast. Okay, it's rising slowly, and because it's rising quite slowly, it's not able to build tall clouds. So it's just able to build these um, stratus clouds. Okay, nimbus stratus clouds. Okay, you can write stratus cloud. That's fine. So and ahead of it, of course, again, you have your cold air. Okay, so cold air again, cold sector. Okay, so this is like a side view, okay, of mid-latitude cyclone, and that should be it, right? Yeah, that should be it. Okay, so right, okay, so let's then move on. So this is the plan view. This is like a top view. Okay, top view, also call it the plan view. Basically shows the circulation of air. In this case, this means that it is in the southern hemisphere because there's clockwise rotation. Okay, right. So let's move on then. That's it. Okay, should be able to know all of this information, guys. Now let's see. So when the cold front, they like to ask the question. The cold front, when it approaches, there are weather changes that are associated with it, and we'll look at them right now. Right. So the first change that we see is the air pressure. So when it comes to the air pressure, we say that the air pressure increases when the cold front approaches or when it has already arrived. So it increases, and and you should be able to state the reason why. Okay, don't just say the air pressure increase. When they say describe the changes, the weather changes, write down the air pressure increases because warm air is replaced. Okay, so warm air is replaced by the cold air. Okay, what did we say about pressure? We said that warm air, okay, warm air tends to rise up, and so it therefore places a low pressure on the ground. But imagine that now you have replaced cold air. Okay, sorry about that, you've replaced this warm air with cold air. Okay, so cold air, what does it do? It sinks down. Okay, so if it sinks down, then it applies a lot of pressure on the ground. Okay, so now if you look at this right over here, okay, so if you take a look at this is you right over here. Okay, the cold front hasn't arrived, it's approaching. Okay, it's coming to you. You are still in the warm sector, right? And now this whole system is moving towards the right, towards the east, right? And so the cold front will eventually reach you, okay? And now you'll be behind the cold front. Now that means that you will be in the cold sector, okay? So from the warm sector, now you are in the cold sector, okay? So if you are in the cold sector and there's cold air, and cold air tends to do what? Tends to sink. And so now, as you can see, the warm air has been replaced by cold air now. So that's why there's a, we say that the pressure increases, okay? Because at first you were in the warm sector, but now you are in the warm sector in which there is rising warm air. So there was a low pressure developing there, okay? But now you have been and the warm air has been replaced with the cold air, and cold air tends to sink, and therefore that's why we're saying that the air pressure increases. Okay, so that's one weather change, guys. Should be able to understand it. Okay, don't just know these, understand them. Okay. The second thing that happens is that wind direction changes. Okay, from west to south, or they can say from the northwest to the southwest. Okay, we call this backing. Okay, so, this type of change in wind direction, we call it backing. Okay, well, I will explain it now. Now, the reason why it changes the wind direction, the local wind direction changes, is because this local wind joins the clockwise circulation of the mid-latitude cyclone. So it joins that clockwise circulation, and hence the wind direction changes. Now let's take a look at an example. So let's say right here, the wind direction was from the west, so wind was coming from the west, right? Now you have this mid-latitude cyclone still over here. Now, when it arrives, when this mid-latitude cyclone actually arrive here, okay, now it's going to, of course, this local wind will now join the wind or the circulation of this air, okay, in the mid-latitude cyclone. Now it's going to be influenced by that clockwise rotation. Now, from coming from the west, it will now come from the south. Okay, so as you can see, because of this clockwise rotation, air actually changes direction from the west, now it's from the south. Okay, so it changes, say that it is backing. Okay, or we can say that it comes from the north. The local air was from the northwest, it joins the circulation, now it comes from the southwest. Okay, because of this circulation, this clockwise circulation. Right, right. Let's move on then. Another change that we see is temperature. Of course, this is one is obvious because warm air is replaced by cold air. Okay, behind the cold front. So again, guys, okay, you had this. You were in the warm sector. Now the warm sector is replaced by the cold sector. Okay, and now in the warm sector, of course, you have warm air, so that's higher temperature, relatively higher temperatures. And in the cold sector there's cold air, and so that's relatively lower temperatures, and so that's why temperature decreases. The cloud cover increases. Okay, so um, from having no clouds, now you have cumulonimbus clouds. Okay, the reason why is because the warm air, if you were in the warm sector, the warm air did what? Um, it rises up, cools down, condenses, forms cumulonimbus clouds. Okay, so from clear skies to being full um, um, full clouds. Okay, like that. Okay, um, yes, full clouds. So now we are forming clouds. So the formation of clouds increases cloud cover. That's what we're basically saying. Okay, I don't want to make it complicated. So because warm air rises over the approaching cold front, it cools, condenses to form clouds. Okay, reasoning, guys, reasoning, very important in geography. And then the type of cloud. So cloud cover and the type of clouds, guys, is not the same. So cloud cover and cloud type is not the same. So you have to put these as different points. Okay. So the cloud type now is what? Is cumulonimbus clouds. Maybe there were clouds, okay, but cloud cover increased. Now you have cumulonimbus clouds. Okay, so cumulonimbus clouds, they occur, as I said, guys, I already stated this, because the steep pressure gradient associated with the cold front forces warm air to rise up rapidly, building tall clouds, which are called cumulonimbus clouds. Okay, so that's what we are saying there, because there's a large mass of warm air, okay, that is rising up. It's going to condense, and when it condenses, it's going to form these huge clouds, because there was a lot of warm air rising up rapidly, very fast, okay, rising up, and they end up building up this tall cloud type, which we call the cumulonimbus clouds. Okay, and then the rainfall type is heavy rainfall. So this is the precipitation, and heavy rainfall, of course, how cares, because it is, of course, associated with cumulonimbus clouds. Okay, or because of the strong convection. The strong convection is what I was referring to, the rapidly rising air. Convection is rising air, strong, that's rapidly rising air. Okay, so that's why we have a heavy rainfall that occurs as our rain type, because it's always associated with cumulonimbus clouds, and cumulonimbus clouds which were formed due to this strong convection, right? So that's it for the associated weather changes with cold front. Okay. Now let's take a look at the impact. Okay, guys, we are just going through everything. Okay, there's no time. I don't want to do a lot of videos, separate videos, so you can get everything here. Okay, I need you guys to rely on me. I need because I really think I do explain quite a lot in one video. So I just hope that you don't miss out on any of the videos that I've done and that I will do in the future. Okay, because I really go in. So let's look at the impact. Of course, mid-latitude cyclones cannot prevent them. Okay, we just have to manage. Okay, good management will result in less damage. Okay, so now let's look at the damage that these do. Okay, so I've separated these as human impacts and environmental impacts. I'll also do other impacts as well, like your tourism, because they have different types of impacts when it comes to exams. Okay, so remind me to do a video of one of those. Okay, one of those or all of them. So when it comes to human impacts, we have positive impacts and negative impacts, and it's very important that you look at the question. What is the question saying? Is it just saying describe the human impacts that mid-latitude cyclones have? Okay, if it says human impacts, then you are describing both of these. Then it's Christmas to you, because there's a lot of points that you can put in there. Okay, whether positive or negative. But if it is specific negative human impacts, then you have to only describe negative human impacts. Positive human impacts, only positive human impacts. Environmental impacts, so you have to really read the question, guys. Very important. Don't rush. Right, let's look at some of the positive human impacts that are associated with mid-latitude cyclones. Okay, now we know that these occur in winter, right? They occur in winter, and crops are different. Okay, there are winter crops, there are summer crops, so on and so on. Okay, so some crops really thrive well in winter conditions, some thrive well in summer conditions. So this is a win for a farmer who's actually planting winter crops, or who has a winter crops, or who lives in these areas where you have mid-latitude cyclones affect the most. So winter rainfall determined type of crops that are cultivated. So, so what we are basically saying is that the winter rainfall that comes with mid-latitude cyclone is actually a good, or provides a good conditions, or the appropriate conditions for winter crops. That's what we're basically saying. Okay. So it's good for the farmer who's still going to generate income even during these extreme conditions, because we have those type of crops that prefer them. So this leads to increased food production, food yes, food production, and hence food security. Okay, and so food security, of course, is our stability. Is when all people have sufficient, healthy, nutritious food, and they have access to it. So that increases food security even during the difficult months. Okay, rain replenishes water in dams. Okay, we know that we are a water scarce country, so this really helps us a lot in terms of restoring water in our dams, so water levels increase for human consumption. Okay, because we are talking about human impact. And then the snow in mountains, it replenishes water when it melts. Okay, because we're going to have cold conditions. This will result in snow in mountainous areas, and of course, these will melt down eventually, filling up the same dams that we have. Okay, and low temperatures are good for fruit farming. So there are some fruits that really prefer lower temperatures, and so that's good for farmers, or for the people who are going to consume these types of fruits. Okay, so excuse me. So those are your positive impacts, and then negative impacts. Um, Flooding. Okay, so flooding can result in the loss of lives of people. I mean, we've heard of this a lot of times in the news. So a lot of people have lost lives, guys, due to flooding. So flooding can be very, very dangerous. Okay, so and mid-latitude cyclones, because um, mid-latitude cyclones are associated with heavy rainfall. Heavy rainfall results in flooding. Okay, so flooding of rivers that results, of course, in the loss of lives of people. Okay, because these occur where people stay. Okay, so in these neighborhoods, and so that's what we are saying there. There's destruction of homes. Okay, due to flooding, due to heavy rainfall. Okay, different types of destructions. Okay, I will not go through that. We don't have time. There's loss of agricultural land. Okay, because flooding that's associated with soil erosion. Okay, so now that your soil ends up being eroded, the topsoil that is necessary. Okay, because it has the necessary nutrients for the plants, your crops. I mean, there's a risk of food security, food insecurity. I mean, because now we're going to lose a lot of agricultural land, that reduces production, and hence that is a risk to food security. Now people will not have enough, not be able to produce enough food to feed the whole country. There's poor visibility and traffic accidents due to heavy rainfall. Okay, so we know this, that heavy rainfall can be a direct causation of traffic accidents, okay, because of the poor visibility that is associated with. Mountain passes closed if there is snow, okay, or mass movements. Okay, so we know some areas that, like areas such as your Chapman's Peak. Okay, you can search that up. So Chapman's Peak in Cape Town, it gets closed during winter because it has rock falls, so you can have rocks. So mountains get unstable, and so of course, if you're driving down the road and you have rocks falling down, so that is a risk to people. Okay, so mountain passes then are closed. Okay, we close these areas to reduce danger to people. Okay, And then the environment. Okay, when they're talking about the environment, please, yeah, if they ask you about the environment, please talk about the environment, guys. And there's a lot. Okay, there's a lot about the environment. We usually think that the environment is just limited things to talk about, points to write about. So the positive impacts include it brings the needed moisture to the soil. Okay, remember, soil needs moisture, crops need that moisture. Moisture, of course, that is water, of course. Okay. Right, so it's good when it comes to farmers. They are happy when it rains because that provides the needed moisture to the soil and to the crops, okay, to photosynthesize. There's a revival of biodiversity, ecosystems, habitats. So some of these um, areas have lost a lot of animals and plants because there is not sufficient water, or there are no rainy days, and so these areas like your swamps, so on and so on, they need this type of climate, this type of weather conditions, okay, so that they can thrive again. Okay, biodiversity, being able to have different types of animals and crops, okay, living in that same environment, okay, ecosystem, that is their environment, the relationships that the living things have with non-living things, habitat, that's where they stay. Okay, so this revives these areas, restores these areas so that they are rich again. Water availability for wildlife, yes indeed. Okay, when it rains, wildlife needs water availability, needs water, and so this provides water to wildlife, okay, to prevent extinction, migration, all of that. Water availability for growth of natural vegetation. So natural vegetation, of course, is not the vegetation that you grow by yourself as a farmer, like your crops. This is like natural, it grew on itself. So it also needs water. Okay, so guys, you just need to separate these. Okay, be smart about this. Separate these points. Okay, when you're writing down. Okay, talk about the biodiversity separately. Talk about the wildlife separately. Talk about natural vegetation separately. Okay, water allows for more grazing land. That's good, okay? Because grass needs water, and so if you have grass, then your animals that you are rearing, they will be able to, of course, feed on these grazing land. So they fill up, so it fills up natural aquifers or groundwater aquifers. Those are the rocks that that store water. Okay, so these are important because we will eventually need these in rainy days. Okay, in rainy, okay, so that's fine. So they fill up, so water infiltrates the soil, gets into these natural aquifers, gets into underground, and so that we can be able to retrieve it, okay, during difficult times. Fill up rivers via surface runoff. Okay, so I fill up these rivers, of course. So if you have a river there, so if you're not aware of, if you're not familiar with surface runoff, that's actually water running on top of the surface or the soil. So it eventually empties into the river. Okay, and so that of course helps the river to fill up. Then the negative impacts, the low-lying areas are flooded. Okay, so low-lying areas are usually at a risk. So when it is flooding, really the low-lying areas gets flooded first. Okay, so that's the negative the first negative impact. The soil erosion increases. Okay, talked about this. That's also an environmental impact. Destruction of biodiversity, habitat, and ecosystem. It can. Okay, so as much as it can revive these areas, it can actually destroy them. Okay, these habitats. Okay, remember soil erosion that will result in the depletion of plants, crops, that results in hunger, in herbivores, so on and so on. So all of these have relationships, guys. Okay, the living things, non-living things, everything. Okay? It's all connected. Damage of natural vegetation. Okay, as I said, soil erosion, flooding, loss of wildlife. Okay, it affects the food chain. Again, increases salinity in rivers. So um, as this um, surface runoff occurs, this water, of course, picks up nutrients along with it, and so these salts end up emptying into these rivers, and so this becomes an um, an environment. Remember, there are plants and animals here, so and they require a particular environment. So this changes the environment for them. So again, it leads to loss of wildlife, leads to damage to natural vegetation. All of these are connected. Saturation of soil. So this is where the soil is waterlogged, when you have like a lot of water particles there because it's been raining a lot, and so now the soil has a lot of water such that it cannot accommodate more water, and that leads up to soil erosion, so on and so on. Rock falls or mass movements on steep slopes. So of course, again, talked about the Chapman's Peak. This ends up, you end up, because it is raining a lot, mountainous areas, they end up being unstable, and hence you end up having mass movements such as mudslides, rockfalls, so on and so on. Let's look at the strategies real quick. So these are strategies to reduce the impact, okay, not to prevent the impact again. So the first one is the monitoring. Okay, monitor the development of mid-latitude cyclones. Okay, there are professionals whose job is to look at the development of these. Okay, so that they can warn people early enough so that they can prepare. Okay, so we should be able to see them while they are very far, while they are developing. Okay, so there should be the monitoring of this development, and this requires technology. This requires investments, guys. Okay, so this you usually see in highly developed countries. People and animals should be evacuated to higher lying areas because lower lying areas are flooded. People should find shelter because it is raining, it is cold, okay, so that they seek protection against cold weather conditions, okay. And not only people, should also be animals, okay, so that you ensure that you do not lose your livestock. There should be provision of food and water to displaced people and animals. Okay, these people are going to evacuate. Okay, wherever they're going to move, guys, they need water, they need food. Okay, maybe there's not enough time to get all of these. Okay, so there should be provision of these by the state. The state also should provide healthcare, emergency services, help people who are injured. Okay, effective early warning systems or communication infrastructure. This helps with the preparation of people. So it helps, while if you have an effective early warning system, everyone or most of the people will be alerted or will know that mid-latitude cyclones are going to affect particular areas during particular dates, set dates, so that they are able to prepare. So helps them prepare, helps them get out of danger, right? Gives them enough time. Plant winter crops that can resist the cold. Okay, this is supposed to be cold. Right? Plant winter crops that can resist the cold. Okay, so can also plant GM genetically modified crops which can resist the cold as well. Okay, that could be a separate point as well. Okay, so I hope I was not too fast. I really hope so. Okay, so this is it, guys. This is mid-latitude cyclones. We're done with that. I think the next video should be based on some of the activities. Okay, maybe let me know in the comments if we should do activities on these. A lot of past papers. I can combine all of them and just can hit them one after the next. Okay. So that's it with me, Latit Cyclones, and I really hope that I've been of good help in this section. So we're about to head into tropical cyclones. She's our next one. So guys, I'll see you in the next videos. Remember to subscribe, like, comment, and share.